So how does a major car maker develop a 4x4? Well, in this interview series I talked to two engineers from Toyota. In part one we covered general development. This part two is all about off-road tech. Then we're going to do drivetrain and dynamics, followed by accessories and specs, and you can read about it on my website. Now also don't forget my 200 series versus 300 series comparo and tech explanation, the reader Q&A and the towing payload and accessories analysis. And now on with the interview. Question about a lockable centre diff. The LC300 retains a lockable centre diff, and personally I'm a big fan of a lockable centre diff, whereas virtually every other car is moving to a computer controlled torque splitter clutch of some degree. Why the decision to retain a lockable centre diff?
Purely durability for the expected life of a LandCruiser, where we want it to be able to last a long time under the driving conditions. The lockable centre diff allows you to maintain that performance. And in combination with the excellent MTS performance, we don't find that the need for that kind of variable centre diff. The system will work with both locked and unlocked. Typically, when you run a locked centre diff, you do get a bit more understeer on dirt. Yes. But yes. The control system, and again with the MTS, because it's not just the brake control, it ties in the VSC, it ties in the throttle, ties in the drivetrain. Whether you're driving with the centre diff locked or unlocked, the system still functions. It is designed so it will work in both open and closed centre diff mode.
So, Ray, you and I briefly discussed this at the prototype stage. So, Toyota has retained a live axle at the rear. Obviously, that's greater unsprung mass. You can't do camber on it, etc. There's a whole bunch of disadvantages. Yet here we are with a live axle. And why is that?
Yeah, look, a live axle actually has quite a lot of technical advantages on an off-road SUV like a LandCruiser. So when we're talking the rear axle, when you're driving, firstly, durability, the front, you're driving on outback dirt roads or off-road conditions, the front tires tend to throw up stones and sticks. So the rear axle cops are hiding, especially high-speed driving. So the fact that the whole axle and everything is encased in a nice bit of steel does help the durability with a live axle. Secondly, from a dynamic point of view, when you want to have a vehicle that's got high articulation and moderate roll angle, a live axle allows you to run a high roll center, which means that the car, this anti-roll bar system doesn't need to do as much work to keep the car flat. So you can run a slightly softer anti-roll bar and still have good articulation. With an independent rear suspension, if you try to go to a very high roll center, you get some negative effects such as scrub, where the wheels move in and out as you compress, you get jacking. So you have to have a trade-off. So typically, an independent rear suspension means you end up with a vehicle that has quite a high roll angle, or you get some strange dynamic effects. Now on the front, it's a different story. A live axle on the front, you do get some strange precession steering effects. You can't run a rack and pinion steering. So the balance of an independent front suspension and a live axle rear suspension for a vehicle such as LandCruiser, which needs to be very durable, have a good balance of on and off-road performance, is currently the optimal layout.
Okay, why can't you run rack and pinion with live?
You can, but it's not very common to do that. And with the main downside of live front axles is you get the precession steering effects, where as you go over bumps, you can get a lot of feedback through the steering. So the independent front suspension gives you that much more fine control of the steering, the geometries and the cambers.
Okay, cool. Now, E-KDSS only on the GR Sport at the moment. Now that, unlike the previous system, is computer controlled, so the computer decides when to lock and unlock, and I believe that's either completely on or completely off. There's no interim.
Yeah, so I'll talk a little bit about the high range side, and then Kirsty can talk a bit about the MTS factor. But yeah, the E-KDSS is it's essentially a split anti-roll bar at the front and the rear that can be then opened or closed by a hydraulic valve. So it's either completely stiff or completely open, but the front and the rear can be controlled independently. On high range and highway driving, the bars are open when you drive in a straight line, so you get the maximum ride comfort, and then it senses using steering and lateral G and other inputs around the car when you're turning into a corner, and it then closes the bar. So both front and rear. And so the advantage of this is you get the ride comfort of no a very soft sway bar, or basically no anti-roll bar, and driving in a straight line. But then in cornering, you get the full benefit of the anti-roll bar, and we can make the anti-roll bars a lot stiffer because they are decoupled when they're not open. So you can have a very flat roll angle on road and good ride comfort in a straight line. Kirsty can talk a bit more about the MTS integration of it.
Okay. Yeah, so in MTS, in off-road conditions, it operates the same way as what Ray describes. So it looks at your vehicle speed and your steering inputs. What changes in high 4 is that the default positions for those change. In low 4, the default position is unlocked, so you get that really nice kind of compliant suspension response.
Okay. Would it ever lock in low range? Side slope, for example, because you might want to control body roll on side slopes.
It stays unlocked the whole time.
Okay.
It is in conjunction with the ABS system. So the ABS system is also still adjusting and providing damping. So while we don't have the anti-roll bars engaged in low range, the ABS system is still controlling body movements.
Okay. Yeah. So Kirsty, if we've got the 300 moving in high range there, could you basically control understeer and oversteer to some degree purely by using E-KDSS and AVS? Because if you sort of stiffen the front, loosen the rear, that sort of thing there, you can almost control the car's dynamics without needing to resort to activating the brakes through VSC or similar.
Yeah, that's a really interesting question. I can tell you in LandCruiser 300, we still focused on that kind of brake application, kind of engine management. The brake application, like we mentioned earlier, is much more, much smoother, much more controllable. It happens earlier, so the magnitude of it is lower and it's quite smooth. Yeah. And both strategies change also depending on what mode you're in, whether when you're in H4. With respect to the suspension, I mean, that's not something that we've looked at that I'm aware of, Ray. You're the KDSS expert.
Yeah, we don't use it as a yaw control. Other than on dirt, it does actually prioritize the front coming in before the rear, because you don't need as much roll stiffness on dirt, and typically then that gives a more stable feeling on dirt. So there is a different strategy in the dirt mode for the E-KDSS to prioritize the ride comfort and stability that you need over corrugated roads.
Yeah. Now, I'm intrigued a bit by AVS, which I couldn't really quite get into much detail on. So as far as I can see, that adjusts the dampers in response to what the vehicle is doing. How exactly does it do that? I mean, is there things like, is it one of those magnet systems which magnetize the dampers and then change the viscosity of the fluid in the damper? Does it change the valving or what?
Yeah, it's got an electromagnetic actuator that it has there's a bypass in the shock, so it can continuously or variably control the amount of bypass. So it has an adjustment for the rebound and compression depending on the position of that of the position of the electromagnet. So it's a conventional shock absorber with essentially a small additional orifice control. And then it responds to steering inputs, suspension inputs, roughness of the road. It computes all this work together to try to optimize ride comfort and then also the body control balance. And actually, when you go into low range, it has it prioritizes letting giving maximum traction and letting the wheels move in articulation.
Okay, so that would. Kirsty, does AVS, is that affected by any of the MTS modes?
Yeah, so the H4 MTS, it's the same as kind of your on-road condition. But I mean, your on-road condition with respect to, your roughness and all that kind of thing. So you still have that kind of programming in the H4. In the L4, like Ray says, it's prioritized to allow that kind of maximum articulation.
Okay, so it's working continuously and it's instantly changing the damper settings depending whether the vehicle is accelerating, braking. So would it help with cornering, control body roll and cornering?
Yeah.
It responds to steering, so it looks at if you're hitting the brakes, it tries to stop pitch. If you're cornering, it will try to flatten out the roll. If it senses you're on a rough road, it prioritizes the comfort and the axle control.
Okay. How would it sense on a rough road? Would it look in low and high speed rod movement, that sort of stuff? Well, you do something with looking at this, how the air comes into the air intake.
There's some proprietary in there, but some proprietary information, but based on wheel speed sensors and suspension sensors, you can and also G sensors, it can take all that information to work out what sort of road condition it is. Yeah.
All right. So without going into exactly why, basically the vehicle can sense whether it's on a rough road or not, and then organise it. And so,
and from an off-road perspective, we found a lot of our LandCruiser owners are telling us that actually a lot of off-road driving happens in H4. So they're driving in conditions like sand, like mud, and dirt. Particularly, a lot of our roads here are dirt. And the feedback they're giving us is that the on-road kind of biased control systems were far too intrusive in these environments. So now in LandCruiser 300 we have dedicated H4 modes for sand, for mud, and especially for dirt. And the dirt mode has been developed particularly with the Australian user in mind.
Okay, so expanding on that then, when you say intrusive, do you mean things like stability control on dirt?
Yeah, particularly.
Okay, so is the recommendation now to drive on dirt roads in H4 dirt?
100%.
Okay.
And I guess you'll find it's an extraordinary level up on the previous vehicle.
Okay, that's interesting. I never found a problem with H4 normally on the 200, but maybe I drive it differently. Who knows? But
yeah,
okay,
consider that 800-kilometre round trip. You might find a few instances where.
Yeah. So, what are the differences then with the H4 dirt mode versus non-dirt mode? Is it just loosen up the stability control a little bit? Does it change the ABS throttle response, that sort of thing?
Yeah, exactly. So one of the things that we'd like to talk to you about is the fact that LandCruiser 300 is a completely new vehicle. It's got the new engine, a new transmission, and a new brake actuator. And so we have much greater control over all of these components now in each of our MTS modes. So particularly, you'll find that the dirt mode. The new brake actuator allows us to have much finer control over the brake application. So if you have a VSC or a stability moment, you'll find that response is much smoother and much less intrusive.
Okay, so could it get to the point where, and I've seen this with other cars, you don't even know the stability control is coming in?
Yeah, it's pretty good. It's pretty good.
Okay, so other high range modes, let's explore that a bit then. So there's a sand mode in high range now as well. Is that analogous to the low range mode?
A little bit more. It's a bit more kind of focused at your kind of high speed, kind of high power output compared to your low floor mode. So your low floor mode, you've got this fantastic situation where it can actually launch in second gear. So you have that really nice kind of control launch feeling. You don't kind of have it shifting kind of halfway while you're out of your bog hole, whereas the high floor sand mode is much more power focused. The other thing in the sand mode that you'll find with high floor is that the VSC is much more focused on line traceability. So you don't have that situation anymore where you need to turn it off to get around in sand.
Okay, so did you say line traceability?
Yeah. So the ability to actually, follow the line that you want to follow in sand, because that, when you're driving in sand, it's very, your inputs are very delayed. So you kind of feel like, you're not going in the direction that you're telling the car to go necessarily.
Yeah. Okay. Line traceability is not a term I've heard before. Does that just mean, I guess, neutral as opposed to no understeer, no oversteer?
Yeah, correct.
Okay. So basically, VSC is just massively reduced, allowing for just much greater slip angles there as well. And there's also the brake traction control recalibrated as well to allow greater wheel slip. Yeah,
100%. So when you're driving in sand, as you probably know, so you need to, in order to generate vehicle speed, you need to have quite a high wheel slip. So the traction control has been recalibrated so that there's nothing to kind of restrict that wheel speed generation.
Yeah. Okay. What changes have there been made to turn assist? Because I noticed that's smoother, more effective, and certainly easier to use now. And I really like the fact it will work with the centre diff unlocked. I know it increases the turning circle, but otherwise it was just a bit of a pain there. So you talk to us about the changes in turn assist and when that might be used.
So turn assist, that was developed, entirely in Japan. We received the car here, we turned it on and went, wow, this is really good. So I can't give you a lot of background in the development of that. But I mean, turn assist is designed for you're in those really tight kind of switchback situations. You've got maybe a really big drop off on this side, and you kind of want to, you need to really get around there without dropping off that slope. So, I mean, those situations, you can really lean on your turn assist to get you out of trouble. It's very similar to a traction control situation. So where a wheel it does recognize that those wheels are locked, and it will kind of pulse the brakes to try and regain that wheel control, that grip.
Okay, cool.
Yeah.
How much reliant is it on the gear you've selected? So does it work more effectively if you're in the right gear, or does it not really care? Let's say that you're going down a hill and you really ought to be in second low, but you've just selected, I don't know, in fourth low or first, a too lower gear or too high gear. What effect does that have on hill descent control? I asked this for driver training purposes.
It's still very effective regardless of what gear you're in. I mean, obviously you get that benefit of engine braking when you're in the lower gear, but whatever gear you put it in, you'll find it'll be very effective.
Okay, yeah, because we still recommend to use engine braking to save on brake wear and overheating. You're coming down a really long high country slog. Also my impression was actually made the electronic systems more effective, but I don't really have any firm data to back up that sort of anecdotal evidence.
Yeah, having said that, I mean, if you're cruising along and you're in third gear or whatever, and you come up over a slope and you've got crawl engaged, I mean, it's not going to let you run away or anything like that just because it doesn't have engine braking involved. It is very strong. The response is still very strong, regardless of whether or not you've got that engine braking support.
When you engage hill descent control or crawl control to go downhill, the vehicle will slowly go to its set speed as opposed to jerkily get there, if you know what I mean. What's that feature called, and how is that developed?
I'm not sure if it's got a particular name, but you're right. So we spent a lot of time ensuring that was the case, and we spent a lot of time with TMC kind of refining that feeling. In the low fall condition, so crawl also incorporates your hill descent. Hill descent is specifically for H4, so you have a really good hill descent ability in H4.
Yeah.
But as far as what that's called, I don't know that we've got it a name. We just say it needs to be smoother.
I know it's called gradient release control.
Okay,
in other systems. So it basically gets there. Okay. Now, what's the minimum speed with DAC now? Trying to get my terms right for trader. Yeah. Is 1 or 2 kilometers an hour, something like that?
Yeah. I think it's 1 kilometer per hour. Certainly in low 4. In high 4, I think it's a little bit faster. I think maybe 3 kilometers per hour. Is that right, Ray?
Yeah. Low 4, 1 kilometer an hour, which is that to get a very smooth control at that speed is actually a big challenge in terms of the resolution of the sensors and the control. And a lot of this we have one of our team members is within Toyota, they've got different off-road licensing levels.
Yeah.
There's only 4 people in the world that are rated at the maximum level, and one of them is in our team here in Australia. Yeah. And a lot of the work in benchmarking is we got an expert driver like him to then go, well, what's the correct speed to go down these different areas? And then the target of the crawl system was to match that speed and his style and smoothness.
Okay, wow, it's modeled like that. That's really interesting.
Yeah.
Okay, now what happens to the sensors if you're going down a hill at 1 kilometer an hour and it's really slippery and all 4 wheels in effect lock, and then the vehicle is then sliding downhill faster, but it thinks it's going slower because the wheel speed sensors are just not rotating?
Yeah, so the vehicle does actually have the ability to recognize that all of its wheels are locked. And what it will actually do is it kind of modulates those wheels like in a traction control situation to try and regain that grip.
Okay, so it's always trying to release the brake pressure, and then it will then just say, okay, it's not working, I need to increase the brake pressure. Is that how it works?
As far as details like that, that's probably a little bit... I can tell you it's very effective, and it does. It's very similar to a traction control situation. So where a wheel it does recognize that those wheels are locked, and it will kind of pulse the brakes to try and regain that wheel control, that grip.
Now, question about cross-axle differential lock. That may be for you, Christy. So I was a big fan. I've always been a big fan of Toyota's brake traction control. It is amazing, particularly in core control mode. I've got a question about that as well. But so I was really surprised to see cross-axle differential locks come in on the GR Sport when the 200 was amazing with brake traction control and the 300's even better. So why did I need to be there?
A lot of that came from just guest feedback, customer feedback. So they wanted diff locks on this car. So, we give the people what they want. As far as evaluation is concerned, we evaluate with diff locks off. So we're always working in the worst case scenario for the vehicle, so we can ensure that the traction control of the VSC, everything was working very well without those additional driver aids switched on.
Okay. Now, I think when I did the prototype test, the answer was that if one locker is engaged, brake traction control doesn't work on the other axle. Is that correct?
Ray, is that the case?
Yeah, that's the case at the moment.
Yeah. I can't answer that because we don't evaluate with diff locks on at all. So.
Okay.
Outside of my wheelhouse, yeah.
All right. So what's the rationale behind that? Because in the Prado 150, which I've tested the Grande, that actually did have it enabled with the rear locker engaged.
Yeah, there is a some protection control strategy part of this, Robert. So it's making sure when you have a diff locked, a single diff locked, and then if you're very aggressive with the brake on the other end of the car, it can create some shock loading in the drivetrain. So okay. it's a protection control strategy.
Okay, got that.
And in the case of the GRS, you do have the front and rear. So if you're in that situation where you feel diff locks is required, you put the front and rear diff lock in together.
Yeah, I'm interested just to explore a bit further with Multi-Terrain-Select. What are the other changes between some of the modes which drivers may notice a difference on?
Well, perhaps I can explain this sort of from the perspective of two different examples, perhaps at polar opposite ends of the spectrum. So the first instance we could talk about is maybe you're doing some rock crawling. So you're trying to maybe get up over a rock step. So when you're rock crawling, you're using potentially quite a low throttle position. What you want is a very controlled, very linear kind of torque output. You want a very tight traction control so you can really stamp on any kind of wheel slip as it happens and really stay in that grip range.
Yeah.
The other thing that you want is you don't want it to be shifting when you're halfway up over that rock step. So, rock mode is very kind of, obviously it's quite focused on driving in rock. Opposite condition, the other end of the spectrum, you've got your sand mode. So you're using quite a high throttle position. You want a high power, you're requesting quite a high power output. You're in a high gear. You want a very kind of loose traction control, as I mentioned, so there's nothing kind of restricting that wheel slip. And the other thing, like I mentioned, that you want is a VSC that's very focused on line traceability. So, that's your rock mode and your sand mode. In between there, we've got dirt, your mud, and your deep snow modes. And LandCruiser 300 is great at all of those modes.
That brings us on to MTS automatic mode. Is that the guts of how that works?
So auto mode. So the first thing that auto mode looks at is actually your driver inputs.
Okay.
So if I go back to what we talked about earlier, so your rock mode versus your sand mode. So you're in rock mode, you're using very low throttle position and you very smooth and kind of controlled. Your wheel speeds are very slow and your vehicle speed is quite low. So we go over to sand mode again. High throttle input's quite punchy. Your wheel speeds are high, your vehicle speed is high. So that's kind of the first port of call that it looks at when it's deciding what mode to be in, is actually your driver inputs.
Okay, cool. All right. And then does it look at what the vehicle's doing more generally than that?
Yeah. So it might look at sort of your pitch and your slope kind of measurements. But yeah, the first decision port is driver inputs.
So that's part 2, off-road tech. Don't forget part 1, development, and stay tuned for parts 3 and 4.